All right, in this particular video, we're going to be talking about the period of sinusoidal functions just from looking at their graphs. So what I'd like you to do when you're dealing with sinusoidal functions, let's focus on the two types of graphs that you might see, okay? One graph is the sine of x graph that looks kind of like this. It goes up, it goes back down, and it finishes right here. And what we're going to do is we're going to break it into quarters, all right? So right here, if this is the midline right here that goes through that sine of x graph, that sometimes breaks it into what's called quarters. So right here, this would be a quarter of the way there. This would be a quarter. This would be a quarter, and then right here would also be a quarter. But if I have a cosine of x graph, now I'm going to put, that's your basic sine of x, all right? If I say, what's the cosine of x? Here you actually start at 1, you go down to -1, then you go back up to +1. And the midline actually passes through right there, and so I want you to see the difference in the way the quarters look in the cosine graph versus the sine graph. So here we've got 1/4, here we've got 1/4. I wish I would have made this bigger, but I didn't. Okay, so this is your sine of x, this is your cosine of x. Just remember, the period is the length of period from the beginning to the end of the cycle. Here, the length of the period is very easy to see. You can clearly see it starts here and it finishes right there. That's the length of the period. In the sine of x graph, the length of the period goes from here to there. Now, in the sine of x and cosine of x, that period is just going to be 2 pi without any alterations. All right, so 2 pi, 2 pi. But when we're doing these problems, we have to find the length of the period. So right now, here's my graph. When I look at this, I actually look at it as a negative cosine of x graph. So I'm going to highlight what I see. I see it go up and back down, and it finishes right over here. So let's think about this. If I were to draw my midline, all right, now how do I know that's my midline right there? Because it says there's my midline right there. So I have this point, and I have this point. So if you think about this, if I'm going to break it into quarters, okay? There's a quarter, there's a quarter, and then from here to here would also be a quarter. So the gap between here and here, I've only traveled 1/4 of the way there. So if I start at 1.2 and here's my next point, which is a 5.2, it looks like I've traveled 4 units. So if I've only traveled 4 units and I've only gone a quarter of the way there, I can just take that 4 units and multiply it by 4, and I got a period of 16 units. So what does that mean? That means from here to here, that gap is 16. That gap is 16 units. So now all I'm going to do is I'm going to type in 16. All right, let's go on to the next one. Okay, now this one, it's kind of hard to see, so I'm going to make it a little bit bigger, but that says -1/2 of pi, so I'm going to put -1/2 of pi. That's where I'm starting. And then this says 3/2 pi. Now once again, it looks like I got a negative cosine of x graph. There's the beginning, then it goes back down and finishes right here. This is the actual length of my period. So it looks like I've already traveled half of the way there. So I've traveled half. So if I'm at -1/2 of pi and I travel to 3/2 pi, what's the gap? What's the gap between those two numbers? All right. Well, the actual gap is like saying, if I let's put a 0 right there in the middle, okay? From there to there is a 1/2 of a pi. From 0 to 3 pi over 2 is a 3 pi over 2. So I can just add these together. I get 4 pi over 2, which is just 2 pi. Now what does that mean? That means this gap right here is 2 pi, which means this gap right here would also be 2 pi. But if I add those together, what would the length of my period be? The period would be 4 pi from here all the way to the other point right there. So I've gone half of the way there, and half of the way there was 2 pi, so I just doubled it, and now I know my period is 4 pi. So this is where you got to be careful. You literally have to type in a 4, and you actually have to type in a pi. Don't forget the pi, and ice cream as well. Oh, I guess I'll pause and do 2 more. All right, let's take a look at this one. Ooh, this looks really complicated. That says we're going from what, negative 7 pi over 4 to negative 5 pi over 4, and we got this graph that we have to interpret. So here's what we're going to do. I'm going to look at this, and I'm going to look at it as a negative sine of x graph. You're like, what the heck is a negative sine of x graph? So let me kind of show you what I'm talking about, and I'll go back. All right, let's go to Desmos real quick. Okay, and I'll just type in, maybe this will make sense if I do this, okay? So here we go. If I just typed in the sine of x, that's a positive sine of x graph. A negative sine of x graph looks like that. You're like, I still doesn't make any sense. So let's control the, let's control where we start. Let's start at 0 and go to 2 pi, okay? And we'll make the steps pi divided by 2, okay? Then let's make the y so we can easily see it. Let's go from negative 1 to positive 1. Okay. Ah, that makes it a lot easier. Now, let's check this out. Let's take away this right here. There's your negative sine of x. There's your positive sine of x. Okay? Positive sine of x, negative. Positive, negative. So when I looked at my graph, here's what I saw. I saw that negative sine of x graph. So let's check it out. This looks like it's pretty easy now. Would you agree the length of the whole period goes from here all the way across? So it looks like I have already traveled from here to here. I've already traveled half of the way. So if I've already traveled half of the way, if I'm at negative 7/4 pi, and I've traveled to negative 5/4 pi, like, what is the gap between those? Well, that's the same gap as between a 5/4 and a 7/4. Okay? So watch this. Ready? Just take your calculator. Just do 7 divided by 4. Take away 5 divided by 4. And that gives me 0.5. It's just a half. All right? So let's take a look at it real quick. Where's my... All right? So the gap between those is just 2/4 of pi, which is a pi over 2. Now, if that's pi over 2, if that distance is pi over 2, then this distance from here to here would also have to be pi over 2. So what's double? What's double pi over 2? That's just pi. So the distance, the whole period from here to here is a total of pi units. So I'm just going to go down. Oh, where is it, dadgummit? Pi units. Yay! Okay, let's do one more. Okay, this looks, once again, man, they like negative cosine of x graphs. Now, if you don't know what a negative cosine of x graph is, just watch, okay? Just watch. So here we go. Let's take a look at our Desmos. So watch this. So there is sine. There we go. So there's a positive cosine of x. There's a negative cosine of x. Positive, negative, positive, negative. So when I look, okay, when I look at this, this is what I see. I see a negative cosine of x graph. So I'm going to break it down into 4 parts. Let's see if this makes sense to you as I'm breaking this guy down, okay? So we know the length of the whole period. The length of the whole period goes from here all the way across to right there. It finishes right in there. So let's break this down. Now, where's the midline? It tells us that's the midline. Okay, so I'm gonna. There's the midline. Okay. Okay. Now, if we break this down, that right there is a fourth. This right here is a fourth. And from here to here is a fourth. So I'm gonna color in the fourths with a different color, okay? So right here, this is a fourth of the graph. This is a fourth of the graph. This is a fourth of the graph. And this is a fourth of the graph. So I'm just going to write, ready? A quarter of the graph, a quarter, and a quarter. So literally from here to here, I've only traveled a fourth of the way there. So we're at a 6.2, and we've gone to an 8.7. So what's the gap between those two numbers? Just take the 8.7, take away the 6.2. Looks like I get 2.5. So this distance right here is only 2.5 units. So if that is a quarter of the way there, what do I got to do with that? I got to multiply it by a 4. So 2.5 times 4 gets me 10 units. So if you go to the calculator, type in 2.4 times 4, you get 10. So what am I going to do on my my problem? I'm going to write 10 units is the length of my period from here till it finishes. I'm done. 10 units. Okay. Oh, finally, a positive cosine graph. I'll do one more for those of you who are still wondering what the heck's going on right here. So if you're like, how did you know that's a positive cosine? So here's what I look. When I look at cosine, it goes down, hits it, and goes back up. So if you're wondering, once again, a positive cosine, I'll quickly go over here. That's negative cosine. Here's positive cosine. Okay. So let me go back. There we go. Now, would you agree the period goes from here all the way to right there? And I've already traveled half the way. Can you guys see how that kind of splits it perfectly in half? So that's half. That's half. So I'm going from negative pi all the way over to a positive pi. What's the gap between a negative pi and a positive pi? That's a total of 2 pi. What does that mean? That means from here to here is 2 pi, which means from here to here would also be 2 pi. So I just got to double it, and that gets me a total of 4 pi. So I just double it, okay? And a student said it perfectly. The period only focuses on your x value. So look, I went from negative pi to a positive pi, which is a total of 2 pi, and then I doubled it. So our answer is going to be 4 pi. 4. Don't forget the pi. Okay. All right, and that's it, guys. That's about all I can do. Hopefully this video helped. Just remember, the length of the period. If you're wondering what the heck you're looking for, the length of the period always deals with from the beginning to the end in a sine of x graph, or from the top to the top, or bottom to bottom in a cosine of x graph.